Right, a bit of integration by substitution with the trig substitution here. I've got an international paper 2022. So I've got this integration, we've got to use the substitution x equals 2 sine u to get into this form and get the exact value. So in this question you must show all stages of it working, so you can't just stick that in the calculator. But I'd take it to mean, do the maths, do the substitution, but then stick that in your calculator at the end just to check you got the right answer. So here we go, x equals 2 sine u. Well, top line's easy enough, it's just 6 sine u plus 2. That bottom line, well, it's going to be 4 minus 2 sine u all squared to the power of 3 over 2. Got to sort the dx out, of course. So if x is equal to 2 sine u, the dx over du is 2 cos u, and then I'll stick the du up here to get the dx equals, and it's going to be 2 cos u du, so that goes just here. I need to sort these limits out, of course. When x is equal to 1, 2 sine u is equal to 1. So sine u is a half. So the u is equal to pi over 6. And when x is equal to 0, I just get u is equal to 0. So there's the substitution. Bottom line's a bit of a mess though, so we'll do a bit of simplifying there. 4 minus 4 sine squared I've got, that's 4 sine squared, which is 4, that's 1 minus sine squared, or 4 cos squared, so I need 4 cos squared to the power of 3 over 2, 4 to the power of 3 over 2 is 8, and cos squared to the power of 3 over 2 is cos cubed. So there's it simplified a bit, and now I can do some cancelling. I've got a cos cubed on the bottom and a cos on the top, so I can get rid of cos on the top and the bottom. Cancel out some of these numbers as well. I've got an 8 in the bottom, so I can divide the top and bottom by 2, and again, because these are both even, and I end up with just 3 sine u plus 1 over 2 cos squared u. We wanted it to look like this though, so I need to break it up into 2 parts. So I'll break it into 2 fractions, 3 sine u over 2 cos squared and 1 over 2 cos squared. And sine over cos squared, well I can write it as sine over cos times 1 over cos. So that's sec times tan, or tan times sec, and 1 over cos squared is sec squared, and that's the form we wanted it in. So we've got to integrate this and stick those limits in. So we check the formula book integration section, and the sec squared, well that's right here. We integrate sec squared and get tan, but sec times tan, well we look down here and there's no sign of it. Oh god, what are we going to do? Deep breaths. We look in the differentiation section because we want to differentiate something to get sec times tan, and if we look here, if you differentiate sec, we get sec times tan. So this integrated is sec, because we differentiate sec, we get sec times tan. We differentiate tan, we get sec squared. So there we go, doing the integration. Lord takes. Yeah, Lord takes us. Don't forget the differentiation section when you're integrating. Anyway, so we're going to put these limits in and get an exact answer. So we want 3 over 2 times sec pi over 6, so half tan pi over 6, and put 0 in, sec u, tan 0. Now, sec of pi over 6, well that's 1 over the cos of pi over 6, and the cos of pi over 6 is root 3 over 2, so the sec is 2 over root 3. Tan of pi over 6 is 1 over root 3, so this is a half times 1 over root 3. The sec of 0 is just 1, because the cos of 0 is 1, and the tan of 0 is 0. And simplify this one, it's really just root 3. This one is 1 over 2 root 3, or root 3 over 6 when I put it in the calculator. And this one is minus 3 over 2, and then I've put that all that in the calculator. 7 root 3 minus 9 over 6, and you can change that into a decimal, work out what this is on the calculator, and you'll get the same answer, about 0.52.